Alright, hell yes. This video is more for my brother. It talks about the mold effect. And I'm trying to debunk it, you know what I mean? Because the mechanism is just so obvious to me. But then my brother was like, well, it's still hard to explain. Even if you have a concept in your head that you know is correct, you have to come up with words and demonstrations to show other people. Okay, so one aspect of the mold effect is it's a whip. And that's not very scientific, but what happens is when, this is like going towards the table, this has a velocity. Like if I just drop it, it's got no velocity right here, but the time it hits the floor, it's got a max velocity. But the cool thing about the chain fountain is that basically the velocity of the chain hitting the ground, just due to continuity, is the same velocity all the way through the chain. And let's say it's even the same velocity down into the bucket of chain that it's actually pulling. So that's different than just having even just a little piece of ball chain, dropping it from a table. It's going to have things have zero velocity right before you drop them, and then they're going to have a max velocity. But because that chain has to have continuity, it's going to, the velocity that it hits the ground with is going to be the same velocity as it's pulling the chain out. And then, yeah, the velocity of the chain in the whatever container or bucket isn't moving, so at some point you'll have a velocity gradient. And I showed that in my first video because Medi had really slow motion footage, and the velocity, it would do this, like the ball chain from around the loop, until it kind of gets up to a continuous velocity, would be kind of jerky. That's just an overview, and we're already 2 minutes in. So here's why the ball chain, but that continuity is important because you have way more mass outside the system, outside the cup, all the way to the ground, than just the small little bit inside. And I was telling my brother, let's say you could simulate the same velocity of this ball chain, like drop it. So essentially, just put this much ball chain in a bucket or whatever, a container, drop this from way high, and then the ball chain will drop, and you should have, the second this hits the ground or goes taut, or before it hits the ground, it's going to take this piece of ball chain and it's going to whip it out. And, there is no, like, you could visualize that. And I will say that it doesn't have to defy gravity and go up in the air, but I would say it'll probably swing out like this. Okay, so, and there's nothing, that isn't even what I'm getting at for this video, but that should just be easy and obvious. That there is a huge amount of mass outside the system. You said due to continuity, this whole mass has velocity. And we're talking impacts. If you have a huge mass and velocity, that's why the end of a whip can break the speed barrier. Because it's just the very end. It's like the fibers on the end, because they have like hardly any mass. So you put an energy wave, and a whip is kind of more of an energy wave, and it waves through the large part of the whip, and you're taking that and you're condensing it down to a smaller mass and a tighter radius and a faster velocity right at the tip. You can break the speed of sound. So anyway, so it should be very obvious that this will fly out and maybe whip out. You know what I mean? It might not. I could even say it's not going to put too much force, and it's not just going to magically levitate the weight of the ball chain. I don't think it's going to levitate the weight of the ball chain. So I will just say that it might have a little bit of force. You know what I mean? If you have this and it's going the upward direction, yeah, it could pull up a little bit. That's for sure. But we just better get to. It was the mold effect video. Steve Mould actually shows this little footage of where he's got like this rope, and he was just like, see, no mold effect. Well, where this is now you have your velocity. The bag gets dropped, and so now you have a lot of velocity. But same thing. Let's say these are the last two strands in the bucket. These are just like, oh, this is so fascinating, because now this is going to whip. Let's say this is the last strand, and just like it was the last strand, this strand is going to whip around, right? So what I was going to demonstrate is the fact that so if this gets pulled and whipped real hard, I would say that this could be your fulcrum, and oh, damn it. It seems so obvious looking at it, but now it's not. So let's do this. If this is the last little bit of the whip, yeah, and you pull real hard, you could just imagine that it is going to whip up into the air. So at some point you could have such a high velocity this way that it whips up into the air. So my proposal is the fact that even just looking at the setup was just like, well, if you have this draped up and over, it actually is even better, because now you do the mold. Oh my God! See, just right there, that debunks the mold effect. Like that's literally it's because let's do that again, because that was insane. That was insane how that worked out just exactly how I thought. And I was just like, okay, so again, so if you have this huge amount of velocity and mass, and you get an upward force, and this is going to be the last links in the chain, but it was just so interesting. But it's just going to pivot right here, and it's going to pivot right here, and it's not going to really do the mold effect. But the fact that you have all the chain in the bucket, you know what I mean? You don't have just a real quick end, so it can, it wants to whip out, but it also, I don't know. I'm having a hard time putting this into words, but I was just so amazed that it actually worked. So you're having this. I'm going to pull on it with a velocity that actually flips this part up pretty good. But because this part is resting like in the bottom of the container, the velocity that it will put on, let's do it one more time. Yeah, and then you get the mold effect. So that is so interesting. Now, I know I'm having a hard time putting this into words, but I feel like this is a success, because I looked at Steve Moll's photo for his just like, yeah, this debunks the mold effect. Well, it was just the picture that he showed. It's like, no, that actually proves it's a velocity problem. You do get a whip, and why this is so much better? Oh, here it is. Yeah, this is worse. Yeah, if I pull on a velocity, you ain't getting the mold effect. You know what I mean? It's the same thing if you have a ball chain fountain, and here's the table, and then here's your ball chain on the ground, and then here's the side that you're pulling. Well, it's just going to neutralize itself. You know what I mean? But with a ball chain, you're saying that your pot is up high. You know what I mean? So it's identical. I was telling my brother, it's like you have to look at the last links of the ball chain, and if you do, you know what I mean. This thing's gonna go up in the air. But the fact that a ball chain is up high, it's this last link's gonna go into the air, but all the other links are already way high in the air too. You know, it's not having to pull this. If I double it up, yeah, it doesn't. It only wants to flick right there. You know what I mean? Right there is where it wants to flick. But so here's this debunks the mold effect. You know what I mean? Or is because this isn't weighted down, and it's already in a more upright position. So when we whip this little piece, this can come and form a continuity ring. You know what I mean? And I'm using just horrible terminology, and we're at the 10-minute mark. Let's just do this one more time and call it a video, because that's all anyone can handle. Whoa. I mean, you have to have that critical velocity, though. So, hell yeah. So we're just going to do right there. Get our velocity. All right, and then hell yeah, you get a little mold jump, you know what I mean, mold effect. But I'm debunking the mold effect. All right, so that's going to be part 4. That's probably the best video, super simple, and finally some concise thoughts, examples, trying to put it to words. It's really hard to disprove something, especially when you have like a million view, you know, scientist person. Yeah, you know what I mean? It's really difficult. And it's not about getting people on your side. I could care less about that. Maybe I don't care less about that. But my brother, he was just like, yeah, I know that you have an idea that you know is true in your head, but it's still a challenge to make it simple and make observations and make scientific, you know, little demonstrations to prove that. So thanks for joining me, and guess what? That's a video.